The last year's experiment of applying urine to grass while there was snow on the ground over winter proved its primary goals that some amount of fertilization was getting through that snow and into the grass below, not just all running off with the meltwater. I wanted to dive into that experiment a bit more to get a better understanding of maybe what was happening, particularly with the peculiarities of the die-off that I observed on one of the sites. So this year I conducted an experiment on more sites. This one I did the kind of concentrated dumping in one hole to like melt through and hopefully soak into the ground immediately. And here I did the same, but just with water, not with the urine. This was the broadcast style one. And again, I used water on this one without any urine in it. And here was a control which I didn't do anything with. The goal of these water experiments was to see if for some reason that broadcast was causing the grass to die off in some way. And what I'm seeing here is that these like water only application plots don't look substantially different than the control. They kind of appear they might have a bit more of the tangleweed bed straw in it, but when I look at the photos I took of these plots last summer, I can see that this area just had more of that in it than like the control plot. So I'm pretty sure that isn't because of the water application. Not certain, but fairly sure. Moving on to the experimental plots. I applied 15 person nights of urine to each of these, which compared to the 36 person nights I applied to last year's plot is less than half. It was in the same time range of starting right near the end of January in through February. This was a little bit shorter, didn't go as long into February and into March, but in general, it's fairly similar. We did have a kind of different winter. This winter was a little bit longer. I'm not sure how much that would affect it, but while I was applying this, the snow conditions were reasonably similar to last year. My intention in doing less than last year was to make sure I just didn't overload these and have like them both just be fully fertilized with no distinction between them. While I'm not seeing much of a distinction between them, I can see that they both have been like lightly fertilized, I would classify it as, in that the grass is darker green, but it's not really growing much faster. And this grass has been growing for a month or so. So I'd imagine I would be seeing a difference if there was like a difference in grass, like grass height. But I look at these and maybe if I did a ton more, I could distinguish differences between them, which is what my hypothesis was, is that the broadcast wouldn't get into the soil as much as the like straight dumping down one. But in either case, there's some amount of it, but I can say that they're both probably receive some fertilization, but not a lot. I'm not seeing any like darker grass of like indicating fertilization outside these boxes, which is good because that is an indication to me that it's not running off much. It's soaking in here and fertilizing these grasses, which is what we want because we want these grasses to act as the treatment for this urine and not have it go into the streams and pollute those with its nutrients. A quick look at last year's experiment shows that the broadcast plot I did still has very dead grass. It seems like when grass dies in these urine fertilization experiments, it really stays dead for a long time. It doesn't come back quickly. The one I did in the short grass, there's still a very dead spot in the spot that I did that with only just a few non-grass plants kind of growing from that well. This area where I was direct dumping it, a lot of the grass is gone. It's mostly taken over by the bed straw, or what we call tangleweed, because it tangles up your scythe when you're cutting it, is why we call it tangleweed. There's some grass in here still, but it kind of looks a little bit dead underneath, which is an indication to me that I may have over-fertilized these, or what I call over-fertilization, I think is not actually physically too much nutrients, which is classical over-fertilization, but because urine contains salts, it's getting too much salt into the soil, and that's preventing the plants from growing. But there's other reasons that grass can die out. Right over here, I noticed this spring there's a lot of little rodent tunnels chewed in the grass, and that area also does not have much grass growth. The tangleweed's coming back into it some, but it's really kind of lacking grass growth as opposed to kind of the general area around.